Hi friends, today we're going to talk about word problems that involve systems of inequalities. Christy sells her photographs at a booth at a street fair. At the start of the day, she wants to have at least 25 photos to display at her booth. Each small photo costs her $4 and each large costs her $10. She doesn't want to spend more than $200 on photos to display. So let's let X equal the small photos. I'm only choosing that because they talk about small photos first. It really doesn't matter which one you choose as X and which one you choose as Y. Write a system of inequalities to represent the situation. So we have one for the total number and the total cost. Total number of photos, at least 25. At least means greater than or equal to. So X plus Y greater than or equal to 25. And then the total amount of money, $4 for each small, so that's 4X, plus $10 for each large, 10Y. No more than 200 means less than or equal to 200. If I got Y by itself on each of these, this would be Y greater than or equal to negative X plus 25. Keep this red here. And then on my second inequality, if I got Y by itself, Y less than or equal to negative 4/10 X plus 20. So let's graph our first one. We have a Y-intercept of 25. It looks like each of these are going by 2, so 25 would be right here. And then my slope is -1. So I'm going to go down 1 and over 1. Again, each box equals 2. And we'll go ahead and draw our line. And this one is greater than or equal to, so I'll shade up here. And then our other equation has a y-intercept of 20, and our slope is -4/10. So down 4 over 10. We'll do that a couple times here. Draw in that line. That one is less than or equal to. So down here, everything under the blue. Remember, we're looking for the shade or for the overlapping region. So this is the part where it would overlap. So anything in that gray area could be a combination of small and large pictures. So let's look here. Could she display 10 small and 20 large? So that's the point 10, 20. Really, we're looking if 10, 20 is in our shaded area. And if I look here, 10, 20 is right here. That pink dot is not in the shaded area. So no, she could not display 10 small and 20 large. Could she display 20 small and 10 large? So 20, 10, we'll see if that's in our shaded area. If I go over 20 and up 10, that's right here. It is in our shaded area. So yes, she could display 20 small and 10 large. A trailer can carry a maximum weight of 160 pounds and a maximum volume of 15 cubic feet. A microwave oven weighs 30 pounds and has 2 cubic feet of volume, while a printer weighs 20 pounds and has 3 cubic feet of space. So again, since they're talking about the microwave first, I'm going to have that be my X, which means Y is my printer. Our two inequalities are going to have to deal with weight and volume. So for weight, the microwave is 30 pounds and the printer is 20 pounds. Maximum weight of 160 means it needs to be less than or equal to 160. And then we have one for volume. The microwave's volume is 2. The printer's volume is 3, and a maximum of 15. Again, if I get y by itself on both of these, this one will end up being y less than or equal to negative 3/2 x plus 8. And for my second inequality, y less than or equal to negative 2/3 x plus 5. So if I graph my red one, the weight, we have a y-intercept of 8. Slope is negative 3/2. One isn't quite through my points. Let's try that again. There we go. And it has to be less than that. So we'll shade on this side of the line. And then for our volume inequality, we have a y-intercept of 5 and a slope of negative 2/3. And that's also less than or equal to, so we'll shade on this side of the line. So again, everywhere in this overlapping region is a combination of microwaves and printers. So if we look here, could they do 4 microwaves and 2 printers? So I want to look and see if 4, 2 is in my shaded region. 4, 2 is right here. So it's just barely in the shaded region, but it is. Could she have 7 microwaves and 3 printers? Or could they have 7 microwaves and 3 printers? So if I go over 7 and up 3, that is very clearly not in the shaded region, so no. One more. Omar needs to eat at least 800 calories before going to his team practice. All he wants is hamburgers and cookies, and he doesn't want to spend more than $5. At the hamburger restaurant near his college, each hamburger has 240 calories and costs $1.40. Each cookie has 160 calories and costs 50 cents. So we'll have X be our burger and Y be our cookies. We have 2 different equations here. The first one for the calories. So for the calories, 240 calories per burger, 160 calories per cookie. He has to eat at least, so greater than or equal to 800. And then for the money spent, each burger is $1.40, and each cookie is 50 cents. And that has to be less than or equal to $5. If I get Y by itself on these, I would get Y greater than or equal to negative 3/2 x plus 5. And then on my second one, y less than or equal to negative 14/5 x plus 10. Graphing my first one, I have a y-intercept of 5. My slope is negative 3/2, so down 3 over 2. that one is greater than or equal to, so we'll shade above. And then for the money, we have a y-intercept of 10 and a slope of negative 14/5. So I have to go down 14 over 5. I think we'll only be able to do that once. There's not enough room to make another point. And then that one is less than or equal to. So we're going to be shading on this side. And if we look at our overlapping region, it's this little triangular region right here. So again, any combination of cookies and burgers that's in that gray region would be possible for Omar to eat. So could he eat 3 burgers and 1 cookie? Well, if we look here, over 3 up 1 is right there. So yes, that is in my shaded region. And then could he eat 2 hamburgers and 4 cookies? That's right here. That's also in my shaded region. So yes. All right, friends, have a nice day.